So if you are taking any international licensing exams in medical lab science, this will be very useful for you. Right. We will go to the question number 1. These are MCQs related to medical laboratory science. MCQ 1, insufficient centrifugation will result in A false increase in hematocrit value. Question B is a false decrease in HCT value hematocrit. And C is no effect on HCT. Answer D is all these options depending on the patient. Right, now we will consider the answers one by one. What is HCT? It is the percentage of red cells in the blood in volume. So to get HCT, we do centrifugation. We centrifuge the blood. So centrifugation is usually done in a microhematocrit centrifuge. So you fill blood into a capillary tube, seal at one end, and place it on the this special centrifuge called microhematocrit centrifuge, and centrifuge it at very fast speed. Then the cells, red cells, will pack at the bottom. So you take the red cell volume as HCT. So this is an example. This is after centrifugation. Okay. This is the cover. So this is how you measure the HCT value. There is a special apparatus. So you place the bottom level at this line and upper level of red cell pack at this level. Then you can directly read the HCT value. So if the centrifugation speed is slow, what will happen? Insufficient centrifugation will result in falsely high hematocrit value. It is false in this because not enough centrifugation to pack the red cells properly. So we will go to the question number 2. Variation in red cell size observed on the peripheral smear is described as this is variation of red cells size. So when you talk about morphology of red cells, the size can be changed and also shape can be changed. So the red cells population, you can see different sizes, or you can also see different shapes. If it is different sizes, it is called anisocytosis. So variation in red cell size is called anisocytosis. So then hypochromasia is decreased in color. Poikilocytosis is variation of shape. Then this has more description about it. A mature erythrocyte approximately at the size of 7 to 8, that is normal red cell, micrometers in diameter. Variation in normal size is denoted by term anisocytosis. So hypochromasia, the increased pale area is increased. We go to number 3. When you go to number 3, which of the following is preferable site for bone marrow aspiration and biopsy in an adult? So iliac crest, sternum, tibia, and spinous process of vertebra. This is the answer. So, iliac crest is the most common site for adults in marrow aspiration for marrow biopsy. So we'll go to some pictures and see. This is biopsy needle and skin. Puncture skin and go to the bone marrow. So you subcutaneous and then go to the bone marrow. The bone marrow needle. So this is the area, iliac crest. Then question number 4 is of mean cell volume is calculated using the following formula. Mean cell volume. Now when you see a question like this, question is about mean cell volume. So we do not have to worry about hemoglobin. So exclude all the answers with hemoglobin. This one is hemoglobin. A and D are about hemoglobin. So we have only 2. So this also, C also has hemoglobin story. So the answer is this one. It's CT divided by RBC. MCV is the average volume of the red cell that is expressed in femtoliters. Femto means 10 to the power minus 16, 10 to the power minus 15, 10 to the power minus 15. So femtoliter is 10 to the power minus 15 of a liter. What femtoliter? Very small volume. So go to question number 5. What term describes the change in shape of erythrocytes seen in right stem peripheral blood smear? So that is easy because poikilocytosis is the term for shape and variation of shapes of erythrocytes. This is changes in shape, various shapes. This is various sizes. So this is poikilocytosis. This is anisocytosis. These red cells have various shapes. Sides. Many ovocytes there. Macrocytes are there. Here it is also different shape, different sizes. In macrocytosis and microcytosis, you get different shapes and all. This is RDW, red cell diameter width distribution. Red cell distribution width is the measurement of variation of sizes. So in the blood smear you can see that, but the value you get in the analyzer results RDW. Normal range is 14% or below. Above 14% is abnormal. In iron deficiency anemia, RDW is high. Hypersplenism is characterized by hypersplenism means that now spleen is the organ which removes the abnormal red cells. So abnormal red cells are removed by spleen when the cells go through the spleen. So not only red cells, even other platelets or white cells, if they are abnormal in character, they have, for example, if platelet has antibodies attached to it, it is removed. Red cells, when all red cells and also abnormally shaped red cells are removed by spleen. So the answer is pancytosis, that is pancytopenia. Pancytopenia is reduction of blood cells in all cell lines, that is white cells, platelets, and red cells. So that is called pancytosis. In hypersplenism, all the red cell lines are reduced because spleen removes these cells. Hypersplenism is a clinical condition. Pancytopenia, splenomegaly. Splenomegaly means enlargement of the spleen. When any organ is enlarged, abnormally enlarged, that is called megaly. Hepatomegaly means enlargement of the liver. Right. Spherocytosis differ from normal red cells in all the following except. Now, spherocytosis, why spherocytes are formed? And what is spherocyte? Spherocytes to go to a red cell, normal. Spherocytes are round red cells. They are round shape. Normally, red cell is a flat biconcave shape. So, spherocytes like the tennis ball. So, spherocyte cannot go through small blood cells, small blood vessels. Why spherocytes are formed? One reason is abnormal. This is the cross section of a red cell, cytoplasm, red cell membrane. So take it out and enlarge. So red cell membrane has these proteins. When there are abnormalities in these proteins, the spleen identifies the red cell as an abnormal one and removes that part of the red cell. So the rest of the red cell form again like a ball. So part of the red cell is removed and the shape is now like a ball. So these are microspherocytes. No pale area. Which of the following is not associated? We will go to the question. The question. Spherocytes differ from normal red cell in all the following except decreased surface to volume, no central fellow, decreased resistance to hypotonic saline, increased deformity. Decreased surface to volume, that is true, because now surface is less. No central failure, that That is also true. No central pale area. Decreased resistance to hypotonic saline. Hypotonic. When you put a red cell into normal saline, nothing happens. But if you put into a hypotonic, that is less strength of saline, so that the red cell will take water and rupture. So the spherocyte is a round one and it is easily ruptured in hypotonic saline. And also increased deformability. This is false. So this is the answer. Yeah, except deformability means the ability to go through small blood vessels. When red cell is flat shape, normal biconcave shape, it can bend and easily go through small blood vessels. But if the red cell is like a ball, it cannot deform, it cannot bend and go through it. So answer here is D. Question number 8. Which of the following is not associated with hereditary spherocytosis? In hereditary spherocytosis, the problem is that with the protein make the red cell membrane. The cross section is here. This is in here. This spectrin is abnormal protein, genetically abnormal. So the cells is identified in the spleen as an abnormal red cell, and spleen takes part of the red cell, and the result is the spherocyte, or part of the membrane is taken. So which of the increased osmotic fragility? What is osmotic fragility? When you put take red cells and put into a series of saline. So this is 0.70, 0.65, 0.60, 0.55, 0.50. But we know normal saline is 0.85% sodium chloride. Here also sodium chloride with this strength from 0.7 to 0.30. We make a forget about this red color. First we make a series of saline strengths like this. Then we, in osmotic fragility test, we add a small quantity of saline. This is 5 ml and we add 0.5, 50 microliters of red cells. And then we centrifuge it after half an hour. What happens when these are close to saline strength? No? So 0.70, no cell rupture. Here also nothing. When you centrifuge, if the cells are ruptured, it will give like this hemoglobin in solution. So up to 0.50, nothing has happened, and here it is started and increased. When it is 0.30, no sediment, no unruptured red cells. All the red cells are ruptured here. So this is called osmotic fragility test. When you use a normal red cell, this is the story. Normal red cell like this. But if you put spherocytes, if the blood contains spherocytes, the rupture start here, like for example, at 0.55. So at here, this color will give by this one. So we say osmotic fragility is increased. This means now the spherocyte is like a ball. No? Normal red cell is a flat one. So it is for a flat red cell, normal red cell, the black water has to enter the cell in hypotonic. Water enters the cell and make it bigger and bigger, then rupture. But in a spherocyte is a round one. Even with little bit of water entering there, it ruptures. So we call it increased osmotic fragility in spherocytes. So this color is because red cells are ruptured, then hemoglobin is released. So in hereditary spherocytosis, it starts here. So very easily red cells are broken because they are in round shape. So we go to the question, which of the following is not associated with hereditary spherocytosis? Increased osmotic fragility? True. Not associated. So this is not the answer. MCHC greater than 36. Mean cell hemoglobin concentration. The concentration of hemoglobin in red cells, we give as a percentage 36%. So it is high, true. Intravascular hemolysis. D, extravascular hemolysis. So these two are not the answer now. They are correct, right? They are true. We have to find the false answer. Intravascular and extravascular. In hereditary spherocytosis, we know spleen removes the red cells. So spleen means removing means extravascular hemolysis. The red cells are removed by the spleen before their normal lifespan. Normal lifespan is 120 days. Before that, remove red cells by the spleen. That is called extravascular hemolysis. So this also happens in spherocytosis. So the answer is intravascular hemolysis, because intravascular hemolysis is rupturing red cells while running in the bloodstream. So intravascular hemolysis is the false answer. So that is the answer expected, not associated. So then we go to number 9. Which of the following disorders has an increase in osmotic fragility? Iron deficiency anemia, hereditary erythrocytosis, hereditary stomatocytosis, hereditary spherocytosis. Okay. All these are, B, C, and D are red cell abnormalities in the red cell membrane. So they have they are abnormalities, but B has a normal shaped red cell. It has a pale area, it has deformability and all. Stomatocytosis is also same. Iron deficiency anemia actually osmotic fragility is decreased in iron deficiency. So answer is hereditary spherocytosis. Out of these 4, hereditary spherocytosis is the condition causing increase in osmotic fragility. We will go to question number 10. Which is the major hemoglobin found in red cells of patients with sickle cell trait? Sickle cell trait is now sickle cell is a abnormality in hemoglobin. They are called hemoglobinopathies. That is, we know the hemoglobin has two alpha chains and two beta chains. So in beta chains, there are two beta chains, one from mother and one from father. If there is an abnormal placement of the amino acid in beta globin chain, position number 5, instead of glycine, valine is introduced there in sickle cell disease. So different amino acid in beta chain. So if one beta chain is changed, that means it's out of two, or if one beta chain is abnormal, we call it sickle cell trait. If both beta chains are abnormal, they have sickle cell anemia. They need every month blood transfusions, and it is a serious condition. Now, in sickle cell trait, most of the hemoglobin are hemoglobin A, because there is one normal chain there, one normal chain in sickle cell trait, one normal beta chain and one abnormal, that is sickle beta chain. So hemoglobin A is the major hemoglobin there. Hemoglobin F is fetal hemoglobin. A2 is a hemoglobin with alpha 2 delta 2. Hemoglobin S is sickle hemoglobin. So the major hemoglobin is hemoglobin A. In normal people, 97% of hemoglobin is hemoglobin A. Now in sickle cell trait, it is 50 to 70% of the total. Okay, we did 10 questions. So I think these are helpful. You have to, if you are taking any license exams, you are requested to do more and more questions. Thank you.